Hello and Assalamualaikum. My name is Iqbal, Muhammad Iqbal bin Umran, under the matric number of 214287. Today I will be introducing into wave equation. So introduction. The wave equation is a second order linear partial differential equation that is used to represent waves. In math, a wave is any moving function. A two-way wave equation is another name for this type of wave equation. Let's review a few terms and definition that will help us develop wave equation before digging further into wave equation. So, a partial derivative of u can therefore shown as here. We can see here. So, for the formula, we have the double differential with c as constant. It's always positive, and for here we have double dot u is a simplified version, and under here is the type of, here we can see from the top here to the low here we have del double dot u and square del. So the application for wave equation, we have gravitational wave, light waves, sound waves, and string theory oscillation. Basically anything that vibrates, it has waves. So this is my example here. So we can see very simple, but of course the final answer is not a number, it's basically the simplified version of the function itself.
Next is heat equation. In mathematics and physics, the heat equation is a certain partial differential equation. The heat equation is used for solving problems in engineering, fluid mechanics, atmospheric science, climate physics, weather forecasting, option pricing, geophysics, and solar physics. This is the formula for heat equation. There are one-dimensional heat equation and two-dimensional heat equation. So let's do an example. Find the solution of one-dimensional heat equation with initial and boundary condition. So the boundary condition is both 0 and the initial condition is fx. So for this question, there are three cases that we can do to find the solution, but the first two cases will give us trivial solution. So it is not a solution that we want. We want the non-trivial solution. So we use the third. So we take the equation given uxt equal to a cos px plus b sin px e power of negative p squared c squared t. Using u 0t equals 0, we will get a times 1 plus b times 0 multiple with e power of p squared c squared t. So from this solution, we will get a equal to 0. So I name this equation 2. So equation 2 will be reduces to u xt equal to b sine px e power of negative p squared c squared t. So we take the boundary condition when x equal L and y equal t, the answer is 0. So b sine pl times e to the power of negative p squared c squared t equal to 0. L can't be 0 and b also can't be 0. So sine pl is 0. So from the angle we got pl equal to n pi, p equal to n pi per l, where n is 1, 2, 3 and so on. So the equation become b sine n pi x per L times e to the power of negative c squared n squared pi squared per L squared times t. So because n is not just one number, we have infinite answer. So we will write the answer with infinite answer. And the solution can be written such as this. So we take the initial condition ux0 equal to fx, where summation bn sin n pi x per l times 1. So we can get the value of bn. Bn is 2 per l integrate 0 to l fx sin n pi x per l dx. Then that is the solution for this equation.
Hello, my name is Iqbal, and I will be replacing my friend in Laplace equation. He is not well right now. So the Laplace equation is a formula, a solution where involve electrical, magnetic, and gravitational potentials, ready state temperatures, and hydrodynamics. It is credited to Pierre-Simon Laplace, founded by him, a French astronomer and mathematician, for finding the equation. So the application for this Laplace equation is to solve any equation involving more than one differential by transforming into simpler notation to solve it. If both potential of surface is known, Laplace equation can be used to find out the potential at any point between them. The Laplace equation can show the state of conduction heat transfer. Here we have the example which involves in the point on the rectangle here. So we can see here, we can go down until the final answer is not in full. It's actually just a simplified version function that can be solved at the end. So this is our reference. That is all. Thank you.